All right, 6.1, chapter 6 is getting us started with our normal distribution or normal bell curves. And we're going to get into finding the area of the shaded region. So right now, this is brand new material for us. So we're going to kind of get the characteristics of this bell. First off, a bell curve represents how your data is distributed, okay? Now the area underneath this bell from one end to the other end should equal 1. It should not go over 1 for normal distribution. So again, the entire area from one end to the other equals 1. Now you see there's a number line at the bottom. That number line consists of something we call z-scores. Z-scores are standardized numbers that are designed to fit on this particular bell. So it's kind of like you can do a bell curve for any data. It's just you're going to have to transfer that data to be z-score numbers to represent or to fit on the actual bell. So if you heard that teachers grade on a curve or whatnot, they're transforming your scores to be z-scores, okay? Now, the normal number line for a z-score goes from -4 to +4. Now, at -4 or at +4, you're starting to taper off. Everything between 3 and 4 gets very, very, very minor, but very close, okay? So normally you'll see z-scores between -3 and +3, okay? Everything after that kind of gets really, really close. So if you have pulled off, I uploaded on Canvas a chart for you to use to find the area underneath the curve. Now on that particular chart, you have you have 4 columns. We have 4 columns. The first column says Z. That would be the actual z-scores. So if you were to flip it or go all the way to the 4th page, you would see 4.00. But if you look up above it, all of the areas in columns 2, 3, and 4 are almost the same number. They are rounded off differently in the 4th place. So that lets you know that the areas for z-scores 3 to 4 or -3 to -4 are finitely close, okay? Now, if you notice, we'll look at the headings for columns 2, 3, and 4. You see portion in the body, portion in the tail, and portion between mean and z. Now, I have some bells to represent these 3 shadings. A body shading, make sure you can see it, is represented where the majority of the bell is shaded. The majority of the bell can be shaded all the way to the left, or it can be shaded all the way to the right. When I say majority, you know this bell has a central point. That central point is going to be 0 or where your population or sample mean would live. Now, if your shading starts and goes over the middle, that's the majority of the bell. You could say that more than 50% of that bell is shaded. Because if it was half shaded, that's 50%. So more than half is shaded, that is a body shading, okay? Body shading will start, go across the middle, and take it all the way out through what we call the tail. Your endings are your tails. So for a body shading, you're going to start at one particular point on the right side, or it can start on the left side and go to the right. But it's got to cross over the middle where it represents more than 50% shaded. That's considered a body shading. Your second type of shading is considered the tail shading, okay? Now, your ends are called tails. You can have very small tails. That would be around the 3 or the 2 z-score. Or you could have very large tails that come up to 1 or -1. Or it could come up all the way to the middle. A tail shading never crosses the middle. It could come all the way up to the middle and continuously go out to the left or to the right, but it would never ever cross the mean, the middle, cross 0. Your tails would never cross over the middle. So you need to be able to know that your tail shading represents your ends. Now, different from the body shading was one continuous shade. Body shading, one continuous whole shade. The tail shading is actually 2 shades. So when you look at your chart and you look under the column for tail, that particular measurement is only for 1 shade. To get the area, you would have to multiply by 2 or add that measurement twice, because this is considered 2 shades, okay? They do not have to be proportionally equal. You can have a tail that's at 1 and a tail that's at -2. If I wanted to know that area, you would add those 2 measurements together. So I don't want you to think they always have to be proportionally the same distance from the middle. They don't. But your second shading is a tail shading. Our last shading, or our third shading, is portion between the mean and z. That's what we call that. Portion between the mean and z. Well, the mean is in the middle. That's 0. And so you're looking at the shade between the mean and a particular z-score. You can go to the left or the right. It does not have to be proportionally equal. Okay, again, I don't have to be over to 1 and over to -1. I could have said from the mean to +2 or from the mean to -3. That would still be considered a portion between the mean and z. Now keep in mind, this is called one portion between mean and z. That's actually 2 pieces. So just like the tail, you would take, if it's proportionally equal from the middle, you would multiply that measurement by 2. If they are unproportional, then you would add those 2 measurements together. So these are our 3 shadings. Recap, you have the body shading, which has to consist of more than 50% of the veil. We have the tail shading, which will be your ends. And they are 2 separate shades. And then lastly, we have our portion between the mean and z. Okay? Now, kind of giving you some examples of what we're going to be doing with finding the area. My first example is I'm going to give you a veil, and it's going to have a z-score listed on it. The z-score is 1.45. Now, the shading represented, you got to be able to identify, is it a body, is it a tail, or is it a portion between mean and z? Well, looking at the picture, more than 50% of this veil is shaded. So this is a body shading, okay? This is a body shading. So if I want to find the area of that red shaded area, you're going to go to your chart. This is what I uploaded on Canvas for you to print off. You're going to go to your chart. Under the first column, you're going to see Z. You're going to look for 1.45. So it's 4 pages. So make sure you flip. It should be on the second page. You're going to go to 1.45. And the first column, well, the second column after Z, is going to say portion in the body. That's a body shade. So the measurement is already done for you. That measurement is 0.9265. So the area is 0.9265. There's no math for you to do because a body shading is one complete shade. So that measurement is already on the chart. You go to the Z-score of 1.45, you look for body, and you find that particular measurement. Keep in mind, from here to here, you can't go over 1. So all of your areas should be less than 1. If your decimal is greater than 1, then you have messed up. That's a body shading. Let's look at our second example. You notice my outside ends, they are shaded. So this is a tail shading. This is a tail shading. So my Z-scores I've listed 1.20 and negative 1.20. So they're proportional, okay? They're the same Z-score, and so that means they have the same distance from the middle, okay? So you're going to go back to our table that you should have uploaded from Canvas. You're going to go under the Z column, and we're going to look for 1.20. 1.20. Now, you're going to go to the third column because the title of that says portion in the tail. This is a tail shading, so you got to give me tail measurements. So if you go to 1.20 and we go to tail, you'll see that that area is 0.1151. 0.1151. Now, this is what I was saying, is that you have actually two separate shadings. Since they are proportional, they're the same Z is what I'm saying. Then I would need to multiply that measurement by 2 because the measurements on your chart represent one shade. Okay? Now, the body measurement I did on example 1 was one shade. But this one actually is two separate shades. So if I want to know the total area, I'm going to take 0.1151, multiply it by 2, or you can add it twice, and you get 0.2302. So the area of the shaded region would be 0.2302. Our third example. This picture would represent the shading between mean and Z. This would represent the shading between mean and Z. Now, if you look, our mean is in the middle. My Z-scores are proportional. You got 0.98 and negative 0.98. So I gave you the same Z-score. So you're going to go back to our chart, and you're going to look for, under the Z-score, you're going to look for 0.98. Now this time, you're going to go over to the fourth column. 0.98, portion between mean and Z, is the last column. That number is going to be 0.3365. Now that area only represents one side. Okay? It only represents one portion between the middle and the Z-score. Technically, if I do both sides of the middle, you have two portions. Okay? They're proportionally the same. So just like with the tail, you're going to multiply by 2, and you get the total to be 0.6703. I mean 30, my bad. 0.6730. So again, that 0.3365 that we got off the chart, it only represents one side. Either one. It only represents one of them. That's actually two sides, two portions. So you're going to multiply by 2. That will give us 0.6730. Our fourth example, it is also a portion between the mean and z shaded. Now I want you to see that I did not make this one proportionally even. If you look at your z-scores, you got negative 1.30 and a 2.10. This is not a tail because my ending is not completely shaded. This would be a portion between the middle, which would be the mean, and z. Now your z-scores are not the same distance from the middle. So you're going to go find 1.30's portion. How far? What's the area from the middle to this number? 1.30. When we look it up on our chart, under the last column, portion between mean and z, that number would be 0.4032. That's going to represent the portion between 0 and 1.30, this piece. Let me say like that piece. Now, you need to find the portion from 0 to 210. So we go back to the chart. You're going to look for 210. Under Z, you're going to go to the fourth column, and his portion is 0.4821. 0.4821. Now, this is not no multiply by 2 because they're not the same. You're going to take both portions and you're going to add them together. That would give us a total area of 0.8853. 0.8853. And I want to show you an example that they do not have to be proportionally the same distance from the middle. Okay? My fifth example. Giving it to you in words. You might need to take, I have some bells that I uploaded in Canvas, and you might need to take out a bell or sketch one on your notes and follow what it's asking you. You might want to do the actual shade. It says, find the area of the shaded region to the right of negative 1.11. So I would draw my bell, or you can use the bells provided. I know that if 0 is in the middle, negative 1.11 would be to the left of it. Now the instruction says, find the area of the shaded region that would be to the right of him. I didn't tell you where to stop, so I would know that it's going to continuously go all the way through the tail. So if I look at that picture, that's a body shading. I have more than 50% shaded. I went across the middle. So I'm going to go get my table back out, my chart. I'm going to look for 1.11 on my chart. And at 1.11, we're going to look for body. Body is 0.8665. Body measurements, you don't do nothing to. There's no adding it together. There's no multiply by 2. It is what it is. My body measurement, the shade of that blue area, is 0.8665. Next example says, in words, find the area of the shaded region to the left of negative 1.24 and to the right of 1.37. So like I said, use the bells provided or sketch it out. I'm going to draw my bell. 0 is in the middle. I know negative 1.24 would be on the left of 0 and 1.37 would be on the right of 0. Now shade what it says. I have a shaded region to the left of negative 1.24. To the left would come this direction, to the left, indefinitely. And then it says to the right of 1.37. If I look at what I just drew, that's a tail shaping. That's tails, because it continuously goes out to the ends. Now, they are not proportionally equal. Okay, they're not proportional. So that's fine. I'm going to go to 1.24's tail on my chart. I'm going to look for 1.24's tail measurement, and it's going to be 0.1075. That area shaded here is going to be 0.1075. I'm going to go look up 1.37's tail to see what that shaded measurement would be, and it would be 0.0853. 0.0853. Then to get the total, I will add the two measurements together, and I would get 0.1928. 0.1928. Now, I did not say this, but I would hope that you would know that when you go look at your chart, there are no negative z-scores on the chart. Because keep in mind, a z-score is a measurement from the middle. So if I am going to 1.37 positive, it's the same measurement if I was going negatively, which means to the left. So they are the same measurement for the positive numbers as it is for negative numbers, okay? So don't let that throw you off. You're just concerned with finding the number. Knowing positive or negative lets you know if it's on the right or the left of 0, okay? Now, this will conclude 6.1. Next, in 6.2, we're going to do some application problems, and we're going to work backwards. Meaning, I'm going to give you the measurement, and you got to match it to the correct z-score.